Alrighty, this is basically episode 1 of what I hope to be a continuing series of broadcasts in which I show the development process in a Sylph project Miyaji, not just obviously to promote the game itself, but hopefully to help other game developers or aspiring game developers with their own projects and to have some idea what it actually takes to develop a video game by yourself, which, fact number 1, it's a lot of work. It's very difficult, and you have to be pretty committed if you're serious about it. So what we're going to be doing today is actually doing some stage design work on Area 12 of Sylph, which is, let's see here, I can find my spreadsheet. That would be the Saturn asteroid base. If you're not familiar with a Sylph project Miyaji, it's essentially based on the 1986 game arts title Sylph, which was their second game, their first game being Thexter. You may be familiar with that. Thexter actually was more popular and it's probably a better, a more well-known game than Sylph, although Sylph actually did spawn several sequels and at least one spiritual successor outside of my own, and was ported, the first version anyway, was actually ported to a ton of different systems. It was originally for the PC-88, which was a Japanese system, but it was famously known in the United States when it was published by Sierra Online. Let me get something up here in the background. Since we're going to work in Blender, let's go ahead and get in Blender. So you're not staring at my boring desktop. Okay, this is Blender. So anyway, Sylph Project Miyaji is, I guess, spiritual successor. The phrase gets overused so much, but it's it's really a reimagining, if you will, that tries to be reasonably faithful to Sylph, the first one. Most people, when they think of Sylph, if they've heard of it at all, they think of actually the Sega CD version of the game, which was extremely popular. But this one really is sticking to the original formula. Very few things are changed. There's a few niceties added, like missiles, ejecting pilots. There's a lot more detail being put into it than was present in the original game. So basically, this is a look at some of the objects that are going to be used to create. You know what? If I could select an object here, it might actually center on it when I rotate. There we go. Now we're getting somewhere. These are some of the objects that are actually going to be used to populate Area 12. What you're seeing here, these are actually going to be force fields. This is just a placeholder graphic in the game. If you've ever seen any of the gameplay videos of Sylph, you probably know what the force fields look like. They're pretty cool. They imagine like static, like a red and blue static, like on an old television, except transparent, basically, and layered. So these metal panels here are going to hold in each of these force field panels. So if you can imagine this, where you copy this over and over again going into the background, that more or less is going to be how this particular stage is arranged. Most of the stages in Sylph actually take place in space. The base stages actually take place in space as well. The main difference is that you're in some sort of environment. In the original Sylph, you were literally inside an asteroid. So if you imagine, space travelers went to an asteroid and cored it out, opened it up and built a base inside the asteroid. That's basically what they were like in the original Sylph. I'm going to try to mix up the formula a bit in Sylph, where all the base stages aren't going to be exactly the same. They're going to be a little bit less boring, so hopefully this one will be fairly spectacular is too strong a word, but fairly visually interesting, more so than just seeing metal walls as you go through it. For example, with this, because the force fields are partially transparent, you're actually going to be able to see the star field background through these, as well as the planet. In this case, it's Saturn, I believe, on Area 12. So it should look pretty cool. I'll also have some asteroids and things floating around on the outside, which will bounce off of the collision tiles. So what I'm going to be working on here tonight is the actual stage itself, the layout of the level, with respect to obviously the geometry here that you see in Blender, and then of course where all the collision tiles are going to end up being. So let me minimize some of my stuff here. Get rid of my spreadsheet, which I just needed because I just couldn't for the life of me remember that Saturn is actually the planet that is displayed on Area 12. Okay, Blender, if you're not familiar with it, is a 3D modeling and animation program. Some analogs to that would be like 3D Studio Max, Maya, Softimage, you name it, any 3D modeling program out there. This is that on crack. I used in the past 3D Studio Max, which I became quite familiar with and thought it was pretty awesome, but I'll tell you what, despite Blender's user interface, which initially you would think is kind of weird or unusual, you know, like Control-C doesn't copy, Control-V doesn't paste, right-clicking does not bring up a context menu, so it does seem pretty alien initially. But once you learn it, you realize they basically made Blender to work like a first-person shooter, where your left hand stays in the home position, you know, with your fingers on A, S, D, and F, and your right hand stays on the mouse. So almost like all the common commands you can execute by keeping your left hand in the home position on the keyboard, and combining those commands with your left hand with mouse clicks and mouse movement with your right hand. So mechanically, as far as where you're moving your hands and your fingers, it's extremely efficient and pretty fast. But I've been using it for a while now, and even still I sometimes forget and screw up, because it's something that you really need to commit the program to muscle memory to have any chance of using it effectively. Alright, jumping to the top view here. Let me find this. Okay, this file here, reference stage area. This I indicates whether or not the object is shown. This is a list of objects, so you can see there's beams at 0, 135, 45, and 90-degree angles. There's connectors. Beams obviously are these long pieces here. The connectors would be these. There's two types. There's this sort of connector here, and see the geometry for it when I go into edit mode. And then there's these connectors over here, and I modeled this all myself. These are not assets that I acquired from somewhere else. But I have used open source assets in the past. There's a particularly good one called Shipyard. So if you're interested in making any sort of science fiction type games, anything that require futuristic guns or ships, anything like that, Shipyard, think of it like a junkyard filled with like hundreds of ship parts or mechanical parts, and you can modify them and assemble them any way you like to build almost any you know, sci-fi type machine, whether it's a ship, a gun, a base, what have you. But for this particular framework here, I'm actually not using that. Okay, go back to our top view here. I'm going to unhide this object reference stage area. This actually shows the size of area 12. Okay, the origin here at 0, 0 is basically the end of the stage. So you actually start offset negatively on the y-axis. So the player ship would actually start somewhere in here. If I make this elaborate, you know, entrance or opening to the base on the level, I may start the player further back, of course, so they can actually see the entrance or the opening to the stage. You can see it's fairly long. It's actually 2,000 units long. your ship in the game is two units wide, so that gives you some idea of the size. Your ship's 2 units wide, the stage is 2,000 units long. Okay, so the first thing that we really need to do here, go ahead and re-hide this. The first thing that we need to do is figure out the actual which places are going to be open and which places the player is not going to be allowed to pass through. The way Sylph works as far as collision is concerned with respect to the environment, the stage, it's relatively straightforward. It basically uses a bitmap image where if the color is black, that means the player's ship can move through it, and if the color is white, that means the player's ship cannot move through it. So what you pretty much do is you can either design the collision for the stage actually using a paint program like the GIMP, for example. You can design it like that first, and then create that as an image in here as a background image, or texture map that to an object, for example the reference stage area object, so you can actually see what you drew in the paint program, which tiles the ship can collide with and which ones it can't. Or conversely, you can actually just go ahead and design the stage with the actual 3D objects first, and then use that as a point of reference to create the bitmap, which the game itself uses to determine the collision tiles. I'm actually not sure which method I'm going to use right here, but we'll figure it out as we go along. I have on my right monitor, I actually have the chat window open, so I got a really late start tonight. It is 1:16 a.m. on the East Coast here in Stone Mountain, Georgia, so I know everyone on my side of the world is sleeping, and also because this is my first video, I don't exactly have thousands of people just waiting for me to get online and broadcast something. They're just watching all the time, but it's all good. In any case, obviously, if anyone wants to jump in and post anything in the chat room, I'll be more than happy to answer your questions. So I think what I'm going to do first is probably create some temporary objects and actually block out the stage. This is actually a technique that's often used in actual studios as opposed to some guy's basement. Whenever they're designing a level, because obviously a level goes through more than one iteration, generally speaking, due to playtesting and feedback from playtesters. So in order to prevent the level designers from wasting an incredible amount of their time just continually redesigning in fine detail a level, what they'll do is they'll use really simple assets like boxes, basically, you know, just like cubes, rectangles, and they'll block out a level where, you know, the things that you can jump on, they're there, they're solid, you know, you can see where the platforms are, where the walls are, where the open areas are, but it's just like terribly simple assets that can be moved around or scaled or modified, and the playtesters will actually test on that until they finally figure out a decent layout. After they get the basic layout, then the level designers will actually come in with the real finished assets and replace all of that, so the level not only plays great but looks great as well. Sylph, of course, you know, is a shoot 'em up, relatively straightforward, simple shoot 'em up. So I don't really need to jump through all those all those hoops there just to get things working. So first things first, I'm going to create a block here. These are 10 by 10 units here. And obviously you can see here these beams, they're actually spaced apart 10 units by 10 units on the grid here. So I'm probably going to create a block that's actually just 10 by 10 units and use that to determine the basic layout of the stage. So in Blender, of course, if you want to create something, just go to Add, Mesh. This is all polygons. There's no NURBs or anything crazy here. It's just pure polygons. Pretty straightforward. We're going to create a cube. You hit T to toggle object tools here. T. The radius here starts off as 1. We're going to make it 5. That way it'll give us an object that's 10 by 10 units wide. G to grab. Hold Control to snap it to the grid. And now let's just put it down here. Z toggles between wireframe and just basic filled shading mode, whatever you want to call it. And the numpad keys actually toggle the view. Like one's front view, 7 are the home keys, top view. So let's shorten this up some. Tab goes into edit mode, so you hit Tab, hit Z. A, by the way, toggles selecting everything. So A. Back to our front view. B draws a box. So we're going to hit B. Grab these guys here. G for grab. Hold Control to snap. And we're just going to keep this pretty simple. We'll just make it 1 unit tall. A, deselect. B, G, hold Control. Alright. Tab to take it out of edit mode, which it shows right here, edit mode. When I hit Tab, boom, object mode. Alright. Back in here, you're gonna hit Z again. And if you wanna get it back into textured mode, you just hit Alt Z. Like that. Okie doke. You know, it's funny, I just started doing this Twitch thing. I had a test, 2 or 3 tests the other night. The last one was finally successful, but excuse me, I'm like so paranoid right now. I'm going to do this like insanely long recording, and I'm going to forget like the one thing that jacks up the whole broadcast. You know, I have my stream muted in Twitch, the actual web browser window muted in Twitch, which is a huge mistake. If you don't do that, then you hear yourself talking twice, and it's a nightmare. I'm just checking everything right now. I'm feeding into my own paranoia. You know what? Everything is good. It's a goddamn miracle. Alright, cool. Okay, so back to Blender here. Now that I have this basic block, sure that pivot point, this little dot in the middle, when you have it selected, that's basically the object's origin, which is, if you think about its location is relative to the origin. So this object's actual coordinates are at this little point here. I just want to make sure that's in a logical place. Dead center from the top, right here at the bottom, so that's pretty good. And this, of course, this red line here, and this blue line here, this is the actual origin of the coordinate system in Blender. So, you can't see it there because it's way up at the top, but let's go find it real quick. Right up in here, that's the origin in Blender. So that's 0, 0, 0. And of course I moved my good old, whatchamacallit, X50Z. It shouldn't be there. Maybe it should. Oh, it should. I'm tripping. Never mind. Okay. So you can just right click, hold down the, if you hold down the right mouse button on something, you just move it around. You see how it moves smoothly, you hold Control, oh, now it starts snapping. So I more or less, I'm going to use these, let's use these as actual collision blocks. And that way we can put all this stuff around them. So these will be the areas that you cannot move inside. And when there's nothing there, those will be the areas that you can move inside. That should make it relatively easy for me once the layout here is done to do the final collision bitmap that the game's actually going to use. I need to stop talking. I need to just start working and stop talking, because otherwise 2 hours will pass and I will have consumed exactly 2 beers, and that's not how we roll up in here. So okay. So these edge pieces here, I'm actually not going to allow the player to enter those, which means the farthest you can go is actually going to be right here. The way the collision tiles work in Sylph is they're literally two-dimensional. They're taken off of a 2D image, which means you can't have like a short collision tile that you can fly over if you move your ship up enough. It just doesn't work that way. So imagine a collision tile extends infinitely up and down. And I'm just doing this whole level design like literally like, you know, from the seat of my pants. There's no real forethought here. So if these are the collision tiles, I'm going to go ahead and put one over here since you can't fly through this part. And let me show this again. Okay, so these are the actual bounds of the stage. Actually, technically you could fly outside of here as far as you wanted. So what these really are, what this large area here, it's not really the bounds of the stage, it's more or less the bounds of the collision data. It's the bounds of the collision data file. So since this entire stage, once you get past the entrance and the exit, is going to be confined to a structure, like you're inside a ship, we need to pretty much keep these collision tiles within here. So hide that again. And the main goal for the stage is to really create branching paths. So, excuse me. So the player will be flying through the flying through the main entrance here. It's all nice and wide and spacious. And then what will happen is they'll see a wall here and an opening on the left and right side, and at that point they have to choose, hey, do I go left, do I go right? And they don't know which way is better, they have no idea what's going to be in there. The paths may branch again, they may merge back together again, who knows? So that's pretty much the idea here. So let's get to it then. The way, if you want to, obviously I'm going to have to repeatedly duplicate this object, so if you want to do that, you just right click to select in Blender and hit Shift D to duplicate it. And you can either move it immediately and snap and left click, or you can hit enter and it'll create it in place, and then you can hit G to grab it and control to snap it. So I'm just going to keep duplicating these guys here. Actually easier if I zoom back. You can see a faint lines here. That's why it allows me to continue to snap. If I keep zooming back, eventually those will disappear like that. Now when I grab it and snap, it snaps it to the lowest resolution of the grid, which in this case is exactly what I need since I zoomed back a bit. It's a little bit difficult to design stages like this, simply because, you know, the way a stage looks here in Blender, when you're essentially in God mode, you know, seeing just the entire stage, which of course will run from here to here, you know, this of course doesn't look anything like what it actually looks like in the game when you're playing it. So it can be a little bit difficult to get a sense of scale when you're designing stages this way. Now, I imagine a lot of modern engines, not that I've used them, but imagine a lot of them actually allow you, they have like built-in level editors which use the engine itself, so you can sort of mock play the game and design it at the same time. I know the editor for the first Far Cry did exactly that. You could run physics on things and such, which of course would be incredibly helpful. But Sylph, I programmed the engine myself, so it has no such niceties. It should just create like a massive array of these or something. Right? And the next 4 hours are going to be me doing this. I'm just kidding. You know what I'm probably going to do in all seriousness, since this is in theory for educational purposes as much as me actually getting work done tonight, what I'll probably do is, you know, just design part of this stage and actually give it a run. You know, go ahead and take the geometry, the actual game geometry down here, and replicate that such that it matches the collision blocks here that I'm laying out, and export that into real game data and try it out in the game and see what happens. So we'll probably keep like an open area here, maybe I don't know, maybe make a bunch of dudes fly out here just to say hi, a little welcoming party when you first enter the base. Then maybe a little lull with some power-ups or something, and then it'll split off into two paths. Again, you know, I'm flying by the seat of my pants here. Okay, I need a sense of scale. I gotta zoom back because, you know, okay, so I need to wrap this up. You can see already I got 1 out of 20 tiles here. Each one of these grids is divided into 10 by 10 units, so if you hit N, that brings up, I don't even know what you call this, properties maybe? Anyway, one of the most useful options in here other than manually setting the 3D cursor, which is this little life preserver looking thing here, is that you can control the grid here, the scale, number of lines, and the most important one is subdivisions. So like let's say you wanted to work with feet and inches instead of just, I guess, you know, the metric system where everything's divisible by 10. You can change these subdivisions here to 12, and each one of these grid blocks will be divided into 12 on all axes. So I actually do that most of the time, but for the stage files here, it's a lot easier to work using base 10. So anyway, and get rid of that. So I'm probably going to leave the opening just this big before I split it off. You know what, maybe a little bit bigger, because you don't want to like piss people off right at the beginning. So let's just extend this out a little bit farther. Hitting Shift D, hold Control, left click. Shift D, hold Control, move, left click. It's actually an option in Blender where it displays on screen what buttons you're pressing. You know, for my next video, if it has anything to do with Blender at all, I'll actually do that. I have no idea how to enable it, or otherwise I actually would enable it right now. Okay, so this is going to be the initial area when you first move in. I'm leaving these not here because this is basically already finished geometry for the most part of how the entrance to the stage is going to look. Okay, so the first 20 blocks here, it's just going to be a wide open area. Then we're going to have a split. I actually need to make this whole thing wider. So it's going to split into two. I'm going to want to have like a center tile. Interesting. I'm going to need to modify this whole thing just a little bit. So let's do this. Let's grab all our dudes here. B again, hold Shift to deselect. Okay. So these guys selected here. And basically want to snap that over one. Like so. Copy these two here, copy this one here, and copy this one here. Get that in texture view so you can see what I just did a little bit better. So I basically just shifted the whole right part over by one block and then filled in the hole that I made. That makes it, or before it was like 4, there were 4 blocks that you could fly through, now there's 5, so there's actually a center path. So I pretty much widened the whole stage area there. Damn cigarette's going out on me. Okay. I need to adjust accordingly. All these guys over here, my collision tiles, grab all those, G, control, move the mouse, left click. Alright, lines up a little bit better. And we're going to do our split right here. So let's duplicate that. Put that here. And I might even, I haven't really, the only thing I've done so far in the stage outside of tonight is created this geometry here, so I'm not even sure if this geometry is adequate to model the stage path splitting off. I sincerely hope I don't need to create more connectors like these, because you have no idea how tedious it was to actually model and get these to like very precisely connect. It was a little bit nuts getting everything to line up. I'm a big fan of precision and symmetry and things not being done half-assed, which obviously comes at a price. Okay, so we're going to have the split here. I might actually want to open that up some. I have no idea how this is actually going to work with respect to the geometry. Without actually, of course, putting the geometry in there. Seems like that's almost what I should be doing, actually. Instead of blocking it out, actually join the disparate pieces down here into a single object so I can copy them as blocks and actually paste those instead of this. You know what? That's what flying by the seat of your pants is all about. Apparently. I'm going to brew up, actually. Alright. I'm doing this the slow way. Just grab all of them and duplicate them simultaneously. Okay. So we have something a little bit more interesting here. So the player gets a little bit of a break with a nice open space. Some enemies that aren't too insane right at the beginning, just to wake them up. Then the path splits, and they must choose left or right. And a lot of games, especially like old school games, the enemies come the same way every time. So it's more or less a matter of just continually dying until you finally memorized where all the enemies are. All the old NES games, almost all of them are like that. The cool thing about Sylph is it certainly supports that random generation of enemies, but it also supports the static creation of enemies where they're in a specific place and such. So a lot of the other stages already do this, the other areas. I basically plan to combine those two things. So yeah, there'll be places in an area where the same enemy comes at the same time every time. Then of course memorization will help you there. But there's other places where the enemy creation, it's what I call a swarm, where it's not purely random, there's different types of swarms, and you can assign each stage its own particular swarm type. And it's a whole routine that determines, really based off of any conditions that you want, which enemies are created and when. So you could base that off the player health or any number of things. So I think through the combination of, you know, semi-random swarms and specifically placed enemies, it should offer a decent degree of replayability without it suffering from what most games that use procedurally generated content suffer from, which is just seeming too random. So it's cool to kind of have the best of both worlds. Alright, so we got our split here. So the entrance, the lobby, if you will, is a split 2. Maybe you want to have it narrow, maybe open on one side and narrow on another side. That'd be kind of cool. So we're actually going to have it. I'll have it narrow here. Narrow even more. Something out there too. This feels really weird. This FYI, actually just streaming the straight up development of Sylph. That's a new one for me, but yeah, it's an experiment. We'll see what happens. And it's kind of boring actually that this one narrows, you know, more and more to the left. It should really shift. Then stay the same on this side. And narrow here. That would mix it up a little bit more. Something like that, perhaps. Now, and I'm wondering if I should actually make the two sides symmetrical or not. I'm not trying to make the game too realistic. You know, part of me wants to say, "Whoa, what would an actual space station or, you know, base in space? What would it actually look like? What would the layout be?" And to a degree, you know, I do think about those sorts of things, but at the same time, you know, it's a game. Ultimately, what you need to think about is, well, what would actually be fun for the player, what would look cool for the player, and not so much what would be realistic. Alright. To get that narrow. Or maybe. It might be cool. No, it's too much. I want to at least initially look semi-symmetrical before it gets too nuts on them. One of the problems I'm actually going to have with the stage, based on the detail level of the beams and connectors down here, is there's no way I'm actually going to be able to use these just over and over again through the actual stage without changing the way the game loads the stage data. It loads everything but the actual modeled geometry here. Sylph actually displays and loads in a really elegant fashion, where you can specify how many blocks forward it displays the information. And it actually only displays what's right in front of the player. But for actual geometry like this, that's been modeled, it pretty much treats the level as separate models, but for the entire stage. So it pretty much draws the entire stage every frame. Even when you first start the stage, it's drawing the last part of the stage in the distance, which for most space stages is fine, but for something like this, you know, if I actually duplicated this framework all the way down the stage, not even considering the splits, it's an incredible amount of geometry. You're talking about probably a couple million polygons, a couple million triangles, which isn't very efficient. So more than likely what I'm going to have to end up doing for base stages for this type of geometry is actually dividing them up into chunks. For example, you know, a 10 by 10 chunk here. It's really a 100 by 100 chunk, 100 units, and having it load, you know, X number of chunks in front of you and not display the other ones. That would allow me to, you know, crank up the beveling here. See, here's the bevel on that. It only has one segment. Ramp that up a couple notches. You can see how that improves the quality of the model. But even with, I already tested it, even with just one beveling subdivision, it jacks it up. Got an anomaly there. What's that all about? Interesting. Right there. See it? I think the two faces are like exactly on top of each other. Not a big deal. Fix that later. So anyway, yeah, I'm pretty much gonna have to rework the way this sort of geometry is loaded by the game, or displayed, but loaded and displayed by the game, in order to pull off a stage like this. And back to what we're doing, basic layout. You know, I think this is actually good enough for now. I'm starting to think though that actually the geometry down here is going to be inadequate to do these turns here. There's going to be no way to actually take this and apply it to this and have it connect. And the same goes for like an endpoint like this. This is designed, as you can see, to be perfectly straight. There's no 45-degree connections across here or across here or anything like that, which means a lot more work for me, unfortunately, creating more of these dudes that fit together in more complex patterns. Tons of fun. Alright. I'm going to pull the plug on this here, go ahead and cut these off. Do one more review. I think I might, you know what? I am going to do that. I'm going to make this a little bit different here. And make some little tight corridor like that. That you have to go through. And it'll get even tighter right here at the end. How much space do I have left in the stage? I got plenty left. Okay, cool. Very good. So you got an opening, you got two there, two there. We'll do right, two there. If these are actually going to connect, they're probably going to need to be wider than just one like that. Now a third layer of redefining the geometry. Okay, get to there. Two. That's pretty good. And we'll get a little bit tighter. Really funnel them in. Alright. And rejoin them here. Put something, actually not quite in the middle, is it? It's underneath, it's wide. That's interesting. Alright. Let me see. That's fine. Alright, seems reasonably interesting. I'm wondering at this point if I should even connect to duplicate this geometry to actually flesh out the collision tiles here. Excuse me. Or not. If you want to see what it looks like, actually, I could actually join these together and create an array of objects. I actually do need to join these together just for the sake of duplication. Okay, let's see if I can manage that. Everything selected except for that one. No. Okay. That one too. Okay. Actually, I need to group these together. I can't even remember how to group objects in Blender, which is unfortunate because that's essentially what I need to do here. If you join objects together, they literally become geometry-wise a single object. It loses the names of each individual piece. So it's not really what you want to do unless you truly intend to join them as a single object. There is a way to group them, however, where you can ungroup them later and they will have retained all of their original properties. And that is what I actually need to do. I need to do that with each block of this, basically, so I can just treat them like Legos and just paste the group over and over and over again to populate the different areas of the stage. Alright, I need to learn how to do that. Let's see. I can figure something out real quick. Here we go. Yeah. How do you do it, fools? Okay. So you just need to designate an object as a parent, and then designate its child objects, then move the parent, and I guess all the child objects will move. Hopefully that will also work for duplication. Okay, Control P. Well, shit. It's easy enough. Just select all the objects and you select the parent object last and then hit Control P. Well, let's see if that works. Which object do we want to be the parent? Doesn't really matter as long as I can remember what it is. The bottom panel, maybe? Okay. Set parent to object, maybe? Okay, so I can still select the objects individually. Again, that's right click. Huh. Ah, okay, cool. So I made the bottom force field panel the parent object, and as you can see I can move these still individually. But if I move the parent, it does this. Question is, what happens if I duplicate the parent? Will it automatically duplicate the children? Let's find out. No, it doesn't. Damn it. Well, there's probably a way to select select all child objects, right? How do you select the parent's children? Good lord, some crazy ass documentation. That's not it. Bueller? Anyone? Yeah, I don't care. It's like reading a math book. Okay. Blender. Damn it. Piece of shit. Well, I think I'll come back to that when I actually figure out how to do it. Otherwise, we're going to be here for a long time. In any case, let's just see what this would actually look like if we did attempt to actually fill these blocks in. Yeah, I'm definitely going to need some sort of connector piece for this. This is going to be a massive pain in the ass. You know, I knew this stage would be something special, but it's turning out to be something extra special. And that's not cool. Good news is, once I get it done for this stage, I'll actually be able to apply that possibly to other base stages as well that are going to use a similar layout. I actually want to have one like this that rather than having force field panels, it actually has regular metal panels, and I'll probably use that for one of the earlier stages. So it'll be more or less progression based on the particular style. So initially, initially you'll see this same sort of framework here of the panels, but it'll look more normal, more like what you'd expect to see inside a spaceship or a base stage. But then when you get to a subsequent base stage that uses a similar style, it'll have the much more dramatic force field panels where you're actually going to be, be able to see the star field through the panels and the planets, any asteroids that may be floating around outside, and it'll be a reward essentially for making it that far in the game. It's always nice to do that, particularly in shoot 'em ups. At least for me anyway. With shoot 'em ups, a big part of what made them fun and what sort of like drove you to push forward and continue to progress in the game was the stages themselves, the actual graphics of the stages. They'd start off relatively boring and simple and normal, but as you progressed, they would get crazier and crazier and more intricate. And so the stage itself, aesthetically, was the reward for progressing that far in the game. So I think I'll more than likely do that. But in any case, I'm probably going to shut things down here. There's the stage at an angle. I'm probably going to shut things down here and try to figure out, do a little Blender research, try to figure out exactly how to select a parent and all of its children automatically, so they're more easily able to be duplicated, and also actually do some more geometrical work, trying to get a panel that can actually connect somehow, either at a straight up right angle, like the actual collision tile block out here is done, or what would really be better would be at a 45-degree angle, so the panels here, instead of just rotating them, like you'd have, this one for example would go fine just here, and it would also go fine here, but instead of making a 90-degree connector, I'd actually make a 45-degree connector going from here to here. I think that'd make everything look a lot smoother. So anyway, I'm gonna do that offline, because that's gonna be a lot of me beating my head against the monitor and trying to figure things out. So in any case, I hope you enjoyed this. Again, I hope this will be the first of many behind-the-scenes broadcasts, really showing what it takes to actually make a game, particularly when it's not just grunt work and you're actually not sure how you're going to accomplish what you need to accomplish yet. Hopefully this will give people that are interested some sort of insight in what it actually takes to make a game. So it was fun to play some exit music here. Again, this is Lunar Voyage. This is actually the song that will be played, at least for the time being, on Area 12 by Morty. If you want to check out Morty's music, you can look him up on YouTube. His Twitter handle is Morty90. And if you want more information about Sylph, Project Miyaji, just go to 8virtues.com/games. You can actually see in the upper right-hand corner the website for the game and Morty's website as well. So feel free to check that out. On 8virtues.com/games, you can also find links to my YouTube account, which has tons of videos of gameplay of Sylph, as well as an arcade cabinet I built recently. If you have any interest at all in building an arcade cabinet, gets somewhat in-depth into that. So anyway, thanks y'all, and